Of course, no polynomial lesson would be complete without talking about division. We're going to actually have two lessons on division. Today we will do monomial division, and then tomorrow we will do long division. So monomial division, I have a trinomial divided by a monomial. In order to do this, I can um, set this up as each of these, 120x to the sixth, gets divided by 2x. 60x to the third gets divided by 2x. And 80x squared gets divided by 2x, right? Everybody is being divided by 2x. And then I can simplify each fraction by itself. So 120x to the sixth divided by 2x would be 60. 6 factors of x on the top, 1 on the bottom would be x to the fifth. 60 divided by 2, 30. 3 factors of x on the top, 1 on the bottom, so x squared. 80 divided by 2, 40. 2 factors of x on the top, 1 on the bottom, x. Let's try that again. I could do this as 24x to the sixth divided by negative 6x squared minus 12x to the fifth divided by negative 6x squared plus 30x to the fourth divided by negative 6x squared. 24 divided by 6 is negative 4. X to the 6 minus 2, 4 power. This is going to be negative 12 divided by negative 6. So 2, x to the 5 minus 2, 3. I've got positive 30 divided by negative 6. So negative 5, x to the 4 minus 2, 2. Okay, here we have 5x to the fourth over 3x squared minus 6x to the third over 3x squared plus 8x over 3x squared. I'm going to do this just so that I get my answer right. So 5 divided by 3 is just 5 divided by 3. X to the second. Negative 6 divided by 3 is negative 2. X to the first. And 8 divided by 3, 8 thirds x to the negative first power, right? Because 1 minus 2 is negative 1. This answer is probably how a calculus teacher would like to see it. That's a good calculus answer. We might have gone slightly differently. We might have done this, and I'm going to accept this as well as an answer. 5 and 3 have no factors in common, and the x squared, more powers of x on the top, minus 6 divided by 3, 2, either plus negative 2 or minus 2, x. There's nothing in the denominator. You could put a 1 there if you want. Plus 8 and 3 have nothing in common. More factors of x on the bottom. So this answer could also look like 5x squared over 3 minus 2x plus 8 over 3x. This is why we always have to be careful about who owns the x. So x with the numerator is exactly the same as x right in line with the fraction bar. X in the denominator must look like x in the denominator. So either one of these is okay. All right, a really big problem. So I have 16 y to the fifth z. Ooh. Y to the fifth z divided by negative 4 y to the second z to the second minus 8y to the second z to the second divided by negative 4y to the second z to the second plus 12yz to the third over negative 4y to the second z to the second. Okay, I'm going to give that there. So I've got negative 4. I'm going to make this a fraction. So I've got y to the fifth divided by y to the second. So there are going to be 3 factors of y left in the top, 1 factor of z left in the bottom. Negative divided by negative is positive. So I've got 2. The factors of y divide out, and so do the factors of z, minus 3. More y's on the bottom, factor of y on the bottom, factor of z on the top. So I'm going to call my answer negative 4y to the third over z plus 2 minus 3z over y. Again, when we get to the more complicated problems, we may have to talk about what answer you're more comfortable with, because I'm comfortable with a couple of different looks.